Okay, we're going to look at setting up a simulation and then interpreting the results. So this situation in an election, 43% of voters chose Governor Smith. We're going to use random digits as a simulation tool to estimate the probability that a journalist will have to interview more than 2 voters before finding the one who voted for Smith. So we want to start by thinking about how we can use this 43%, because even though there are 2 things that can happen, they either voted for Governor Smith or they didn't, it's not 2 equally likely outcomes. So we have to look at the fact that 43% is 43 out of 100. So we needed to pick a tool where we could have 100 equally likely options and use 43 of them to represent voting for Governor Smith. So 100 equally likely options, the best way to do that is a random number generator. So I'm going to use a random number generator or a random number table that uses the numbers 00 through 99, because usually you can pick 2-digit numbers, so we don't want to go 1 to 100. Although you could. This is a little bit easier. So then we have to decide what outcomes we want to use. So of these 100 possible numbers that we could get, we want 43 of them to represent voting for Governor Smith. And those would be our favorable outcomes, the ones that we're trying to count and look for. So I usually like to start with the lowest ones and work from there. So our favorable outcomes in this case are going to be 00 through 42. So it looks like it's 42 outcomes, but don't forget about counting the 00. So there's actually 43 different ways that we would get a random number that would count as voting for Governor Smith, which would mean our unfavorable ones, the ones that are not voting for Governor Smith, would be 43 through 99. So we've decided what numbers are going to represent what. Then we need to think about how we would set up a trial in this case. So if we look at the question, they want to know the probability that a journalist would have to interview more than 2 voters before finding one that voted for Smith. So we have to set up what our trial would be. So you want to think about what you could possibly get to know how many times we're going to have to pick a random number to represent each of these situations. So it could be that on our first number that we pick, we get a value that's from 00 to 42. So we get a vote for Governor Smith on the very first person that we asked. So it only took us 1 voter to get that vote. So that's one possibility. It could be that we don't get it on the first one, but the second person that we ask, they voted for Governor Smith. So the second number we picked was something between 00 and 42. So that would mean it took 2 voters. If we don't get it on the first voter or the second voter, then that means it's taking us more than 2 voters. Those are the people we want to count. So we don't actually have to do a third pick to know if it takes more than 2. It might take 3 picks or 4 picks or 5 picks or any amount of picks higher. If we don't get a voter for Governor Smith on the first number or the second number, then that means it's going to take over 2 voters, and those are the ones that we're going to want to count. So we only have to, for our trial, pick 2 random numbers. So if the first one's between 00 and 42, it only took 1 voter. If the second one is between 00 and 42, but the first wasn't, it took 2 voters. If neither one of them are between, then it took more than 2 voters. So we're going to look at these results. These were simulated results, and you could do it yourself, but this is just a table so that we can all get the same outcomes here. So if you look at the first trial, so this first row here is representing a trial. We got a 0, 2, and an 85. Well, 0, 2 is representing a vote for Governor Smith. So here's a vote for Governor Smith on the first number that we picked. So it doesn't matter what the second person did. It only took us 1 voter in order to get a vote for Governor Smith. On the second trial, we've got 70, which is a vote for someone other than Governor Smith. And then we've got 13. Well, that's between 00 and 42. So this is a representation of the second voter picking Governor Smith. So it took us 2 votes before we got a vote for Governor Smith. On the third trial, 97 is not for Governor Smith, neither is 56. But it might happen on the third or the fourth or the fifth pick. But right now we know it's going to take more than or greater than 2 votes. On the fourth trial, 32 is a vote for Governor Smith. So is 24, but it doesn't matter. It only took us 1 voter to get a vote for Governor Smith. Next trial, 60 is not for Governor Smith, neither is 58. So we needed more than 2 voters to get Governor Smith vote. Next one, we've got 41, which is a vote for Governor Smith. So is 30, but we got it with just one voter. We got someone that voted for Governor Smith. Same thing happens in the next one. 29 is a vote for Governor Smith, so is 12. So it only took us one voter to get a vote for Governor Smith. Next one, 62 is not Governor Smith, neither is 83. So it's going to take more than 2 before we get a vote for Governor Smith. The next one, the same thing happens. 54 is not Governor Smith, neither is 78. So it's going to take more than 2 voters. And then the last one, 20 represents a vote for Governor Smith, so does 18. So it only took us one vote before we got a vote for Governor Smith. Okay, so now we're ready to count up so that we can get the probability of having to interview more than 2 voters before finding ones who voted for Smith. So let's look at which of these had more than 2 voters. So this trial took more than 2 voters. So did this one, so did this one, and so did this one. And we did a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 trials in this table. So the probability that it's going to take more than 2 voters, according to this experimental probability with a simulation, is 4 out of the 10, which would reduce to 2/5. So you could leave it a fraction, or you can change it to a percent and say 40%.